Okay, class, picking up where we left off at. We have here the first tick mark of the vertical axis represents an average age of 20 because of this break here. So it's jumping from 0 to 20. So this first tick mark is 20. But let's take a look here. If you look here, if we went to the year 1980, we would need to go up here from 1980. We will go up to where this point is plotted. And if you notice, this lines up directly with age 22. So this is basically saying that the average age of a woman's first marriage in 1980 was the age of 22. Now, if we went here to 1990, you go up here to this point, it lines up with the age of 24, and so on. Now, I want to scroll down here. It says example, using a line graph. The line graphs below show the percentage of high school seniors who use alcohol or marijuana during the 30 days prior to being surveyed by the University of Michigan's Monitoring the Future study. Now it says alcohol and marijuana use by United States high school seniors. Now we have marijuana use from 1980 to 2006, and also alcohol use from 1980 to 2006. And if you notice, there's no break here, so this goes from 0 to 10% and so on. And it goes by the average of 10s here. It says B, find an estimate for the percentage of seniors who used marijuana in 1990. Now if we come here, we had the year 1990, and we notice our point is here. It's almost at the halfway mark. So we can venture to say that it's approximately 14%. Okay, now we come to B. In which 5-year period did the percentage of seniors who use marijuana decrease at the greatest rate? Well, if we look back up here, the greatest 5-year dip in marijuana use for high school seniors happened between 1985 to 1990. So we can write that out as 1985 through 1990. It says here, in which year labeled on the horizontal axis did 50% of the seniors use alcohol? Now if we go here, we want to go up to 50%, and we want to line this directly up with this line graph, which is here. So when we come down here, this will be the year 1995. So it'll be 1995. Now, we scroll to the next page. It says estimation with mathematical models. Mathematical modeling is the process of finding formulas to describe real-world phenomena. The formulas found, together with the meaning assigned to the variables, are called mathematical models. These formulas model or describe the relationships among the variables. Example, the graph below represents the median age of the U.S. population. It has here the grand of America, median age of the U.S. population. It says here A, estimate the yearly increase in the median age. Now if you notice here, there's a break here. So that means this jumps from 0 to 25. And if you notice, it's more consistent after 25, each going up by 2 years. But all of this here is from 0 to 25. So estimating the yearly increase in median age, we notice here that we start with the year 1970 and we will go to the year 2010. So we will look at the age here. In 1970, the age here is approximately 28, and in 2010, the age here is approximately 38. So we will have 38 minus 28 divided by the years. So we add 2010 minus 1970. So 38 minus 28 is 10. 2010 minus 1970 is 40. Now, when we divide this out, this will give us approximately 0.25 because we're dealing with approximations here. So that the yearly increase in the median age is approximately 0.25 or 25%. Now for B, it says create a mathematical model that estimates the median age M of the U.S. population X years after 1970. So this is what we need to do. We would take these values that we had in A and use them in B. So we would have M, it's the median age, so we had M is equal to. Now the first thing we must do is take our value or the age from 1970. You always take the age of your first year. So that'll be 28. And then we would add. We will add this value here. This is our rate, which is 0.25. And we'll multiply by X, which means the years after 1970. And this is our model. This is our initial age plus the change or the yearly increase multiplied by the years after our starting year, which is 1970. So as M equals 28 plus 0.25x. Now we scroll down here to C. It says use the mathematical model from Part B to project the median age of the U.S. population in the year 1995 and 2020. So we had M is equal to 28 plus 0.25, and then that will be multiplied by, now remember this is years since, your X is years since 1970. So you add 1995 minus 1970, which will give us 25. So it'd be 0.25 times 25. So now, when we multiply this out, you can use your calculator. It'll be 28 plus 6.25. So 28 plus 6.25 will give us approximately 34.25. Now, that would be the median age in the U.S. In 1995. And we could also round this to the nearest whole number. So then this would be approximately 34 years old. So it'd be 34 years old is the approximate age. Now, we also want to use 2020. So we had M is equal to 28 plus 0.25. And remember, we have to take this 2020 minus 1970 because this is since 1970. 2020 minus 1970 is 50. So it'd be 28 plus 0.25 times 50. So now we will add 28 plus 0.25 times 50 will give us 12.5. So we will add 28 plus 12.5, and that will give us approximately 40.5, or if we approximate it to the nearest year, to be 41 years old. And that would be the average population age in the year 2020. So it'll be 34 years old for 1995, and it'll be approximately 41 years old for 2020. And that is it.